It's my real pleasure here to have Eugene Charniak, and I'm told that's his name. And anyway, that's a story you can ask later. I was told a bunch of not true facts that I will not share. But he is a fellow of AAAI. He went to MIT a while ago, and a long time ago, yeah. He's done spectacular work in many areas, I guess most notably parsing. And he also happens to work in the town that I grew up in. And I went back there many years ago. And actually, do you all know what the Brown corpus is? That's from this from Brown University, which is right. At any rate, I managed it. I was surprised that you at that time didn't know Henry Kuchar and Nelson Francis. Well, you knew of them, but you hadn't met them, and so that was quite a. And this was probably just at the time that you were really getting started in the parsing stuff, right? Or just was it?
I don't. It seems to me by the time I got started in parsing, I knew it.
Right. So it was probably a little before that. That is, the empirical revolution hadn't quite happened then.
It's happened to me yet.
Right. Yeah. Anyway, so now I think we're going to hear what happened after all that. Thank you very much.
So, my name is Eugene Charniak from Brown University, and I'm going to be talking about EM and a new model for pronoun resolution, or Pronoun-Anaphora. And this work is with my student, Mika Elsner. So, anaphora is the process of a piece of text referring back to something mentioned earlier in the text. In general, in this area, you don't use the term refer, because that term has been stolen by the logicians. And so when you say something refers, you mean Eugene Charniak refers to this thing here. Anaphora is used when you want to just say some piece of text doesn't refer to another piece of text. It is connected somehow, and that connection is called anaphora. Anaphora resolution, therefore, is determining what that other thing is to which this thing is connected. So when Alice fed the dog, he wagged his tail. The he is said to be anaphoric with the dog. Or another way to say it is the antecedent of he is that is the dog. And we were just talking about connections between pieces of text.
So unlike the logician, in this case, the something is also a piece of text.
That's right. I mean, but intuitively, of course, none of us actually believe that. Intuitively, both those things, in some sense, they're co-referent. And in both cases, they're talking about me or some internal model of me. But we don't need to go there. So the goal of this talk, or the goal of the research, was to produce an unsupervised program for resolving pronoun-anaphora. That is, get a program that can take a piece of text, see the pronouns, figure out to whom, what the antecedents are, and furthermore to do this without any training data, without marking up any text.
Sorry, no training data, or just not annotated?
No annotated data. That's what I meant. In general, there is an absolutely immense literature on pronoun-anaphora. I'm not going to discuss it. The work most directly related to this work, well, we were inspired by some old work done at Brown by Niuji, John Hale, and myself back in '99. Some recent work at Berkeley, Hagigi and Klein's model, sort of got me working in this area again, although this is quite different from theirs. After this work was done, we discovered a fairly similar approach done by Cherry and Bergsma. And if you're interested at the end, I could go into the differences, but that is the work that's closest to the work I'm going to be presenting. Okay, so there are many kinds of pronouns. And in this talk, I'm only going to be dealing with so-called personal pronouns like I, you, he, she, etc. There are other kinds of pronouns like, for example, demonstrative pronouns. This, that, those. Interrogative pronouns, who, which, and other types. And mostly when people talk about Pronoun-Anaphora, mostly they're talking about personal pronouns, and that's all we're going to be dealing with here.
Where in this division you put it? Is it on the personal side?
It is on the personal side.
So it's the dog, it bag which stays.
Yes, the it is personal. Now, personal pronouns come in several types. Some appear in subject position. I ate the food. Okay. Some appear in as direct objects. So you don't say the food made I sick. You say the food made me sick. But on the other, conversely, you don't say me ate the food. So the point there is that the pronouns come in two types, and where they appear syntactically determines which kind you're going to be using. Similarly, there are possessive pronouns, my, his, her. Jason, did you have a question, or are you just...
I did actually, but why don't you finish what you're saying?
Okay. There are reflexive pronouns, myself, himself, herself. In all these cases, the choice of pronoun is determined by the syntactic position or role that the pronoun plays. It is not determined by who the antecedent is. And therefore, it is of no interest in this talk. Okay? And I'm now done with this slide. So would you like to ask your question?
Yeah, I was just curious about possessive adjectives versus nominals. So you have mine, but not mine. Although you do have hers.
It's just, I wasn't making a complete list here.
Okay, so but you're including all of them.
Yeah.
And when you say they're of no interest, what you mean is they're a challenge. You'd like to make sure you don't worry about the fact that I, me, mine, mine are all variants which could be referring to the same entity.
Well, we're going to handle all of them, of course.
Yeah.
But since they don't play any role in figuring out to whom you are referring. So in that sense, I'm going to just, since they don't play any role, they're of no help to me, I'm going to ignore them. Pronouns, however, do have properties that are of interest to us. Okay? Probably the most obvious is singular versus plural. Okay? I versus we. We refers to a group of people. I refers to an individual. Okay? You can refer to either, but he versus they. Okay? So we do care about person because obviously that's, I'm sorry, we do care about singular plural distinctions because that's going to give us constraints on what the antecedent might be. Similarly, pronouns appear in first, second, or third person. I versus you versus he. And again, that can give us clues. Again, quite obviously, gender. Okay, he, she, it. English has so-called semantic gender. That is to say, who the antecedent is determines the gender of the pronoun. It is not just this word has this gender, as in French, say. So again, that provides a constraint, and needless to say, we should be using that constraint. Okay, and so these are of, again, great interest to us in this talk. Now, one thing that complicates all this is that not all pronouns are anaphoric. That is, not all pronouns have an antecedent. And there are two basic cases where a pronoun may not have an antecedent. Firstly, the pronoun may have a referent, i.e. there is something in the world that this pronoun is co-referent with, refers to, but there's no piece of text that describes this entity. And thus, as far as we're concerned, there's no antecedent. So that's one possibility. The second possibility is that there is no thing in the world that this pronoun refers to. Okay, so consider Alice got married. It is unfortunate that her relatives do not like him. So her has an antecedent, Alice. Him has a referent, namely the person Alice is intending to wed, but no antecedent. It has neither. Okay? The it in it is unfortunate. There's nothing in the world. It's just required by the syntax. Now, in that case, you look.
I was going to say, I could argue that
You
both
could,
her
but
relatives,
Hmm?
her relatives do not like him is the referent of it.
No, it's that her relatives do not like him is, if anything's co-referent with it.
You're really stretching things, okay? I mean, you could argue that, but it's not clear what point that would have. Okay, and then what would you do with "it is raining"?
I was going to say, this
You know, weather, those so-called weather it's. It is hailing, it is snowing, you know. So in either case, we're just going to say that this noun phrase, this pronoun, has no antecedent. And in my talk, I'm only going to count things right if furthermore, if I guess that it has no antecedent, then it better have no antecedent. And if I do guess that it has an antecedent, then I have to figure out correctly which one it was. I am not required to guess why it doesn't have an antecedent. Okay? Now, we're going to try to learn this without any labeled training data. So therefore, we need some sort of probabilistic model, well, at least given that I'm a probabilist, I need some sort of probabilistic model that is going to allow me to do this learning. And one of the simplest is to take a generative model and apply EM to it. Okay? So what is our generative model? Well, it's quite simple. What we're going to generate are the pronouns in a piece of text. We're not going to generate the entire text. We could, but that's much more complicated than anything I need to consider here. All we're going to do is we're going to generate the pronouns. So we're going through a text. Every time we see a pronoun, we say, hey, there's a pronoun right here. I know all the noun phrases prior to it, but I want now to figure out what is the antecedent by generating the pronoun on the basis of the antecedent. Okay?
Are you told the pronoun type?
Yes. Basically, you have built into the system, you know there are things called reflexives, things called et cetera.
Right. So you cover up the him part of himself and have to get that. You still know there's a self there.
Yes. You don't know what the properties of reflexives are. You know, that they tend to prefer things in the same sentence. In fact, they have to have things in the same sentence. But you do know that they are a particular class, and the model does condition on that information. So it implicitly knows that they are an important property. So the model then is take the text every time you see a pronoun, generate the pronoun, like it, he, she, whatever, on the basis of the following generative model. First, we're going to guess the antecedent, and then, once we've guessed the antecedent, we're going to guess the pronoun. Very simple. Okay. To be slightly more precise, we're going to, here's the equation, the basic equation. The probability that an antecedent is I, where I is some index into the previous noun phrases, is, well, we want the argmax of that, find the I that maximizes that, is the probability that first, that just given all the antecedents, a priori you would pick the ith. And that can be based on things like the syntax you've already seen, how far back it is, whatever. Once you've guessed that, now you, in some sense, know who the antecedent is, and now you can produce the gender of the pronoun based on who the antecedent is. Of course, again, you don't know a priori that Mary is female. All you know is that Mary will have a gender, and you've got to figure out what that gender is. But if you figured it out, then you generate the gender based on the antecedent. You generate whether it's first, second, third person based on the antecedent. And you guess, is it singular or plural based on the antecedent. Okay? In this, we are going to make one horrendous assumption, which is here. So I want to make this explicit. These probability distributions are fairly unobjectionable, and it's fairly intuitive what they mean. This one is not. What it ought to mean is, what is the probability that the antecedent is I, given all the information about all the possible antecedents? Well, there's too many. Okay? So we are going to make a drastic assumption, namely that the probability that A is I only depends on the information we know about I and is independent of everybody else. Now this has horrendous effects. In particular, this isn't a probability distribution anymore. So you say, well, we can normalize, anything can be normalized and made into a probability distribution. So we can just normalize it, but that just means now that our probabilities aren't well-founded. Okay? In particular, the maximum likelihood is no longer a good estimate. Hell with it. Okay? We're just going to do it anyway. Okay.
I did have a question.
Yes, but I wanted to make this perfectly clear, okay? That yes.
I can imagine what you're basically saying is take the universe of all potential antecedents in the universe, and there is a priori probability that any of them would be referred to by a pronoun. And given a particular set of antecedents you're seeing in a piece of text, you restrict that probability to that set. But otherwise, it's like choosing a ball from an urn. You just choose.
Well, it doesn't help, because it might sum to more than one with this pentagon.
Yes.
Right. But I had a
It might be that there are two antecedents that both look tremendously probable, like 99%.
Right. Or more likely, actually. In general, they're going to sum to less than one because there's no probability constraint that any one of them has to, that someone's got to be the antecedent or that it's got to be non-referential. Yes?
So there's nothing in here, though, about disjoint reference or C command?
No. There's nothing in here about disjoint other than it, for everyone, it picks the best, but nothing in the probability
You know
model.
what I mean by
that's-
disjoint
yes.
reference, though. Within the clause, you can't have two things. A pronoun cannot refer to another noun in some clause.
You're talking about things like reflexive, probability of reflexive
if it's
distribution?
not reflexive, then then it couldn't refer
Right.
to anything else. And C command is supposed to be important too.
Yeah, it doesn't have that.
Yeah, I was going to ask about the simple information.
But you're talking about a very small percentage of the situations.
No, but for example, once you get the gender number person, and which antecedent it's a pronoun of, you're saying that there is a he or a him or his will get decided by the syntactic.
That is correct.
So that's in that sense you're obliterating their identity.
Yes.
But then once you have the syntactic context, I thought, let's say that it's a subject. Then I thought you would condition P of A equals I on the fact that the position you are trying to assign a pronoun to is a subject of a verb, and we want to bring in the verb as.
Ah, yes, absolutely.
Okay.
I'm not so.
It's not just about only the antecedents, the syntactic stuff is.
This,
There's an implicit conditioning on the entire news story and all of this, right? Everything you observe.
yeah, in principle. In practice, of course, there's too much information there. Most of it I don't know what to do with. But yes, so this doesn't, if I is in subject position, that is a very important fact about I, because things in subject position tend to be topical. And things that are topical tend to be the antecedents of pronouns. And I do use that explicitly.
No, I itself being in the subject position wherever it appears, but what about the position where you're assigning a pronoun?
No, I don't use any information about that
Because
except
if this is a
with.
pronoun that eats, you couldn't have a piano eating. whereas
Oh,
it's
oh.
eating.
Let's wait on that.
Okay.
It turns out I do use that information, but it doesn't help very much. And I forget if in this talk I actually talk about it. Yeah, I'm going to have to go on fairly soon, but yes.
So basically you're saying argmax of probability of A to a given news story, and then you're actually forgetting about the news story, so you're just restricting your support to the antecedents that we're seeing in the text, right? So where is the language that was in the text used here? Like, for example, you want to find the antecedent of correct pronoun, right? So, and like, where is the structure? Where is grammar used here? Like, you're just saying
The structure of grammar is only used insofar as that it identifies the noun phrases in the story. And I'm restricting consideration to things that have antecedents, which there's a noun phrase that denotes the same object. But that's it.
So you're just doing a hard alignment and then choosing those as a, like you're just using those.
Yes. Okay, some details. I'm assuming that all sentences are parsed. The results I present later are, they are on Wall Street Journal tree bank examples, but they're examples from development data, so the parser was not trained on them. Okay? And I'm going to be presenting the results of the parsers I use are going to be those found by my parser, not the, quote, true parsers. In fact, there's only about 0.5% difference between the two if you have the true parsers. So it's not a big deal, but just to qualify it. I'm going to assume that any noun phrase that is the antecedent has to be either in the current sentences or 2 sentences back. This is just a hard constraint built in. It's right about 95% of the time. And when I talk about an antecedent, essentially the only things I note about it are its head and the part of speech of the head. And again, the part of speech of the head is determined by the parser. So in the yellow flower, basically flower is the head, and its part of speech is singular common noun. And then basically that's all that's remembered about it. So here's an example. Most of these numbers are made up. So suppose we have Alice fed the dog, he ate the food. And suppose that just a priori we believe that, and these are made up, that antecedents in the current sentence have a probability of 0.2 being correct, In the previous sentence, 0.15. In 2 sentences back, 0.10. Notice that this doesn't add up to 1. That's because of the assumption we made 2 slides back. The probability that Alice is masculine is 0.01. This is actually a real number determined by my program. 0.92 feminine and 0.07 neuter. In point of fact, it's hard to imagine a real Alice being neuter, but my program, you know.
Your program's unsupervised, so it's figured
Right.
this out by EM, so
Yeah.
sometimes it gets it wrong.
Yes, exactly. Dog, it's actually fairly uncertain between masculine and neuter, but there's some significant probability that it's feminine, and this strikes me as sort of reasonable. He knows, it definitely knows that that's masculine. Okay.
Did
Yes?
you figure that out through EM, or was that just?
It figured that out through EM.
Okay.
That is, EM in that particular case converges to 1. Okay, so basically what we're going to do is we're going to multiply this times the probability of masculine, feminine, neuter, and there will also be a person, but since everything here is third person, that's not going to enter into the decision. And you just multiply them all together, and you find out that Alice is 0.0015, and that dog is 0.075, and so we picked the dog. And mostly that's, of course, due to the fact that he is masculine, and therefore dog is much more likely than Alice, which is presumably what's going on here. So now the next question is, how do we get these numbers? And the answer, as I said, is through EM. Now, does everyone here know EM? I'm assuming not everyone does. How many people know EM? Well, there's one person who doesn't.
The first year, so.
Okay. So let's briefly talk about what EM is. EM stands for expectation maximization. And here's the way I like to explain it. Let's start out with supervised learning. So suppose we had a lot of text with every pronoun labeled with its antecedent. And now we want to know what's the probability of getting a feminine pronoun having Alice as the antecedent. So what we do is we find the maximum likelihood estimate. We say, how many times does a feminine pronoun have Alice as an antecedent, divided by how many times any pronoun has Alice as an antecedent. Okay, and that would, and similarly, if we want to know what's the probability that a singular antecedent will have a plural pronoun, then we would, again, compute the maximum likelihood estimate. No problem. Assuming we have supervised data. Okay, so we hire 10,000 graduate students, and we set them to marking things up. But a strange thing happens. About once every 20 pronouns or so, the person is unsure what the antecedent is. This does happen in about 5% of the time. So what do? Well, we could just say, ignore it. Or you could say, well, ignore it unless you're 80% sure that it's one of them rather than the other. But actually, the best bet would be to count it, but assuming that one's 80% and one's 20%, just to count it not as saying, well, here we have one example of Alice and she, or whatever it is, but we've got 0.8 of an example, and similarly 0.2 of another one. And we call these partial counts because you're sort of uncertain about what the truth is, so you count them in proportion to the probability that it's one versus the other. Well, EM is just doing this in spades. Okay? So what EM does, or what I'm going to do, is I'm going to start out with everyone's probability being equal. You're completely uncertain. You have no idea of which one's correct. Okay? So the probability that Alice is feminine equals the probability that Alice is masculine equals the probability that Alice is neuter, all with 0.333. And we're going to multiply all the probabilities together and come out with our answers. Now, at first glance, it's not obvious that this should do anything. The first time you see EM and you're told to do this, you say, huh? This doesn't make any sense. At least that was the first time I saw it. Because if all the probabilities are the same, why aren't you going to get everything equal at the end of it? And the answer is because even though the probabilities are the same, the who occurs where isn't the same. And so let's make this explicit. Suppose that I have a singular pronoun at some point in the text. And I look back at all the noun phrases in this and the previous two sentences, and I ask, what is the probability that any one of them is going to be singular? Contrast that with the case where I don't have a pronoun here. Or I have a pronoun, but I don't know that it's singular, I don't know if it's plural, I don't know what it is, just anything. Contrast those two situations. Well, in the first case, assuming that this pronoun has an antecedent, there has to be at least one that is singular. Assuming that singulars go with singular, which is another assumption that the program doesn't know, it has to learn. But it's true by and large, and so in the actual situations you will find that if there's a singular pronoun here, the probability that any of the antecedents will be singular goes up by just a teeny bit. Conversely, if it's plural, the probability that any one of them is going to be plural goes up, in this case more than just a little bit, because plurals aren't quite as common as singulars, and so therefore there was a greater chance that none of them, say, would have been plural. Well, EM basically notices these very small changes in distribution. So even though each one is just as likely, there'll be more of the right ones than there will be of the wrong ones. So EM picks up on this and then magnifies it. You start out with everybody being equal. Because the distributions of what actually occurs in the world aren't equal, the probabilities change just a little bit. But the next time when you compute the probabilities, they aren't equal anymore because you modified them in the first round. And so this pushes you even more toward one or the other. So things diverge. And interestingly, they diverge in the right way. So for example, if we have an antecedent that is singular, what's the probability that a pronoun which has that as an antecedent will be singular? Well, in fact, it's probably pretty close to 1. Well, we get 0.93. EM doesn't get it quite right. Notice it the other way, by the way. If you say we've got a singular antecedent, what's the probability that the pronoun will be singular? That is less than 1. So there are examples like you are talking about some company, which is a singular entity, and then you talk about they, which is plural. So their EM is even actually, their EM, again, is uncertain, but there the uncertainty is warranted. But it basically gets things right here. By the way, okay. Or considered, again, gender. These are real numbers, by the way. Everything I'm presenting in this section are the actual numbers that the program learns. What's the probability that Paul has masculine pronouns associated with it? In this case, 0.96. That's about as close as EM is going to get it. Paula, 0.92 feminine. Okay, that's pretty good. Pig. You may or may not remember in the last election there was a big question about do people put lipstick on pigs, and does that mean that pigs are masculine or feminine? Well, I actually have objective data on this question. And the answer is they are mostly masculine, despite what the Republicans said, and somewhat neuter and not terribly feminine. Piggy, on the other hand, is completely feminine, and presumably I guess you don't even have to be a native English speaker. I think Sesame Street has been translated into every language, and so everyone knows who Miss Piggy is, and sure enough, it nails it. Okay.
So what corpus did you use with sufficient examples of Piggy to get?
This is amazing. This was the North American news text corpus. Los Angeles Times, New York Times, so we had basically 1 year of 5 different newspapers, and there were enough, we used 500 million words, of course, to get this sort of accuracy on these sorts of words, you need lots of text, but we've got lots of text. Okay, that's not a problem as long as you are using unsupervised methods. Walmart, it again definitely thinks it's neuter. Now this thing makes a few mistakes. Husband and wife, it completely reverses. And the reason is because anytime you talk about husband, what you're really talking about is some woman, and now you're talking about her husband, and so everything you've been talking about is this woman.
What if it's my husband?
Yeah. So at any rate, it generally it just gets those two reversed. But by and large, it does very, very well. Here's another one. Suppose you want to know, is this first, second, or third person? Okay. Here, it's very useful also to know if the antecedent and the pronoun are in a quoted context or not. And to see why, let's consider 2 different cases. Suppose that neither the antecedent nor the pronoun are in a quoted context. Well, then what you see is that if the antecedent is first person, there's a huge chance that the pronoun will be first person. If the antecedent is second, similarly, and if the antecedent is third, similarly. Now let's change the situation. Now, suppose the antecedent is in a quoted piece of a text, and the pronoun is not. Well, if you think about it, the antecedent, someone was saying I, and now you're not in quoted anymore. So whoever that I is now probably going to be described by that person's name. And so the piece in the non-quoted text is probably going to be third person no matter what, and sure enough, that's what you see here. So if, in this case, we had a first person antecedent, but it was quoted and you're not, then you're probably going to still be third person. Similarly for second and third. And again, these are all learned by EM. This leaves one more distribution. What's the probability that an antecedent is likely, something's likely to be an antecedent, just given where it appears relative to the pronoun, without any information about the pronoun itself? And there are lots of things that you would think might be relevant. So earlier we discussed the syntactic position of the antecedent. If it's in subject position, subjects are much more likely to be antecedents of pronouns than objects, and they are in turn slightly more probable than non-objects, things like objects of prepositions. Okay. So, for example, Alice was talking to Mary. She, ... is more likely to be Alice than Mary, everything else being equal. Okay. There are lots of other things, however, that we might take into consideration. Is the antecedent a name? Things that are names in general are more likely to be antecedents of pronouns than things that aren't. Because if you gave something a name, it's probably important to the story. If you just said some other person, blah, 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 well, that person probably isn't important, and you are less likely. Okay, so we ought to condition on that. All told, this probability distribution is conditioned on 3 possible sentences, 3 possible syntactic roles, subject, object, and other. The 6 different places, 6 different binned buckets about word position of the antecedent. 3 buckets for word position of the pronoun. That's one case where I do look at where the actual pronoun is. And 3 possible different pronoun types, because if you are a reflexive pronoun, your distribution over possible antecedents is very different than if you are possessive, for example. In particular, reflexives are invariably in the same sentence. Reflexives and their antecedents are invariably. So I don't know if I got my arithmetic right here, but this number is about right. All told, I've got about 2,500 parameters that have to be set by EM. Now, I emphasize this because normally the common wisdom, and certainly my belief, is that if you give EM this number of parameters, it's going to do you in. Okay? It will do something completely unintuitive that you won't like. But in fact, here, that doesn't seem to be the case. If you look at what it's doing, I'll be with you in just a sec, it seems to be doing reasonable stuff. So if you ask in general, if the antecedent is itself a pronoun, or the antecedent is itself a proper noun, or the antecedent is itself a common noun, what's the a priori probabilities? And they go up, and pronouns are the most likely, which makes sense. Proper are the second, and common are the third. And I think if you think about it, that makes perfect sense. Similarly, if you say, look at where the antecedent is in the sentence. Things at beginnings of sentences intuitively are more important than things at ends of sentences. And sure enough, things in bin 0, which is position 0 and 1, counting 0-based, have much higher probability than things that are 3 or 2 to 5 or whatever this bin is, which in turn are more likely than this bin. And similarly for syntactic position. Subject is more likely than object, which is, in fact, these 2 numbers are very close. Probably this is not statistically significant. But subject being more probable than neither of them definitely is. So Jason, and then...
So if I understand right, you are doing no back off, no max end, no smoothing.
That's right.
You're just taking... So the distributions you've written here are not actually directly estimated. You're estimating a distribution conditioned on the conjunction of 6 different things.
Yes.
And that's why you have 2,500 parameters. And what you're showing here is some average of...
That's right. This is a geometric mean of the parameters.
Yeah, your parameters are actually much more specific.
That's right. But they, so I can't claim that every single one of those is right. All I can claim is that that the general trends you would expect are in fact there.
Yeah, you probably would have had to do some smoothing if you hadn't used half a billion words of training data.
Presumably, but 500 million words of training data cures a lot of ills, as I'm sure everyone knows. There was a question, yes?
So your parameters for overhead dams as well, right?
Yes,
Not in this distribution.
not in this one, but for the gender.
So that's the only head sensitive parameter?
Well, again, let's say yes for the time being, because all the results I'm going to show you don't depend on, are essentially covered by what I'm presenting. But the model did have some stuff where it looked at the governor of both the pronoun and the antecedent, with the idea that if the Jack ate it, and you look at, say, pizza, the probability that its governor is 8 is much larger than piano. Okay, and you ought to be able to use that information. And so my model actually does use that information, but very sparingly, and it makes almost no difference. And why this is the case, I'm not quite sure, but I can speculate in question time if you're interested. We've also done things like trying to use Google 5 grams for the same purpose and gotten no improvement. So here I'm just using 500 million words. Google 5 gram is trained on I don't know what, but it's a lot more than 500 million. Still couldn't find any improvement. Now, the one complication I haven't talked about is non-anaphoric pronouns. Here the governor does help a little bit, okay? So important, if your governor is the verb important and you're an it, then you're much more likely to be non-referential or not non-anaphoric. So that helps a little bit, but again, it's very small, okay? So in essence, all the program really does is there's just some a priori probability, and this I must confess, I just set this based on the development data. I did not actually let EM loose on this. I'm not sure what it would have done, but I don't trust it. So this parameter I actually did use some supervision. Okay, evaluation. Can't have a good statistical talk without evaluation. So basically, what I decided I would do is pick some reasonable metric. Turns out there are zillions of different metrics that one can use. Find other programs online, run them, see how you do in comparison. What I am not going to do is take all the literature, quote their results, and compare to that. And the reason is because, quite frankly, I don't trust the literature. There are, in this field, it is comparatively uncommon for people to write a program, evaluate it, and put it online so other people can run it and check your numbers. Okay? I'm used to the parsing literature, where if you don't put your program online, no one takes your numbers seriously. Okay? And so I decided I was just going to go the same route here. And so I just found the programs that you can actually run yourself and use them as my benchmark. I asked a help group, I think it was the Corpora reading list, for programs, and there were 4 suggested: BART, Guitar, Java Wrap, and OpenNLP CoRef. So we downloaded all of them and ran them all. Okay?
Eugene, is one of them from this guy Baldwin?
One of them was developed here at a workshop. Is that the one you're talking about?
You know, there's Rick Baldwin and the other guy.
I don't know. I forget who wrote these. Anyway, these are the ones I could.
Sounded like it says program.
I think one of them is, but at any rate, scoring. So as I said, I'm going to score in the following fashion. First, you have to guess, does this pronoun have an antecedent or not? If you guess it does not, then you're only correct if that indeed is the correct decision. If you guess it does have an antecedent, and in fact that's the correct decision, then you have to guess the antecedent, and if you guess that correctly, then you get it right. Okay. Now, let me just see here. There is, even here, there's some ambiguity. And I will show this in a second. But at any rate, this particular metric was made most explicit. I'm not going to say he's the first person to use it, but he's the first person to write it down in the form which I understand it. And he called this resolution etiquette. So here's an example that's going to help elucidate this final ambiguity. Alice, the dog, and he. Basically, what I'm going to say is that you start out with collections of noun phrases and pronouns. And the goal is, and now you remove all the pronouns, and the goal is to put the pronouns back in the same set from which you had just deleted it. And the intuition there is that every set has at least one non-pronoun, so you didn't remove everything. This actually turns out is not true, but it's close enough. Okay? So that's the semantics. You remove all the pronouns, and for the ones that you claim have antecedents, you put it back into some set. If that's the set where it was removed from, you get it right, otherwise you don't. Now notice that that has the following property. If you have Alice, the dog, and he and his, the he and his, assuming they refer to the dog, were not put back into the same set from which they came, and thus they are considered wrong, both of them, even though they are in fact co-referential, and this agrees with that. Now you can argue one way, you can argue the other. This, needless to say, is much more, is less forgiving than a metric that says, well, he and his are in fact co-referential, so mark that as right. Okay? This metric says that's wrong, and so we're just clear about that. Yes?
Just to clarify, your training and testing method, when you generate the list of candidate antecedents, you don't allow a pronoun to refer back to a previous pronoun?
I do,
because
but
you have to, because it might never have been given, referred to by full.
well, in that case, I'm going to, the scoring mechanism is going to get screwed up, but really I do it because the original noun phrase might have been 3, 4, 5 sentences back, and it's only current because 2 sentences back there was a pronoun. So that's why. So I let it refer back to the pronoun, but in fact, it's only, you can only get it correct in that sense because the correct thing is in the transitive closure of the set.
In other words, if you have a pronoun and you determine that its antecedent is another pronoun before it, and then correctly, but then you make a mistake in assigning the antecedent of that, you get both wrong.
That is correct.
Yeah, this actually leads to an interesting point, that a pronoun might actually legitimately refer to more than one referent in your set. And although your model doesn't have explicit, well, because you might mention the person twice in the previous 2 sentences. So there might be more than one right answer.
Yes.
So it's not the case that the different antecedents really have to sum to one, but you enforce
Right.
the decoding that there's only one antecedent.
That is correct.
As well.
Yes. And any other antecedent has to be part of the transitive closure of the set that you find for the one that you picked.
And one last detail, the dog, it's a multi-word string, and so you're now counting with your parser to bracket the candidates correctly, or?
In fact, I only require that I pick the head noun correctly.
Good. So in the end, you're down to one word.
Yes. And the trouble with the, I don't think things would change much if you required the bracketing to be correct, except then then the question is the antecedent the dog or the dog who I left on the porch? You know, and you get into silly questions like that, and who cares? So this simplifies things immensely. And I thought, let me just continue. How are we doing on time, by the way?
Yeah, maybe 5 more minutes.
Okay, well, we're almost done. So the experimental data, we use section and zeros and 1 of the Penn Tree Bank, which were hand annotated by NEU G and were used in this paper I mentioned earlier. Section 0 is the development set, section 1 is the test set. Needless to say, the numbers I'm reporting are all on the test set. In fact, the numbers for the development set are exactly the same. You know, modulo bit and noise. So it does not seem that we're overfitting anything. And the reason, of course, is, well, I mean, you can unconsciously overfit by modifying your program in some way. But of course, we're not using the development set for training, so no reason why we should particularly overfit. Section 1 has 1,119 personal pronouns, of which, according to NEU G, 906 are in fact anaphoric. For unlabeled data, as I said, we used 500 million words of North American news text. And this consists of about 750,000 news articles from New York Times, Wall Street Journal, Los Angeles Times, and 1 or 2 others. So here are the comparisons with the 4 programs that I mentioned. Let me start out with this warning. Okay, these comparisons are tricky. And they're tricky because, for example, none of the programs have the same output conventions. So they all mark their answers in a different way. So you've got to, for each program, write a somewhat different scoring program. Okay? And there are other things as well. For that reason, both I and my co-author wrote the scoring programs separately. And when we finally got all our scores to jibe, those are the numbers we used. So we think that we did everything fairly, you know, but certainly there's plenty of room for error here. So here are the results. BART, we don't believe we ever got it working. The numbers were very poor, much lower than everybody else's. And the only real explanation is that just the code wasn't working. So we wrote them email saying that we couldn't, you know, that something was wrong. No one replied. Probably whoever wrote it just has moved and, you know, whatever. And so we got no reply. Guitar does not handle possessives. So we only evaluated it on non-possessives. Okay, so then again, the numbers are not strictly comparable, but it would be unfair to give it possessives as well. That would be artificially hobbling it. Similarly, Java Wrap only handles third person. So again, we only evaluated it on third person. Of the previous work, the best was OpenNLP. OpenNLP initially did worse. We found that there was a bug in it. We actually found a bug in its output. We wrote to the fellow who maintains it. He did respond, fixed the bug, and this is the result after the bug fix. Our program clearly does much better than all of them. Okay, that's a huge difference. This is, I think, the number for the program for the version that's online. There's a newer version that scores slightly better. This one has just a terrible hack in it that I hate to talk about, but so that's why it's not in the talk. But if you ask me, I'll tell you in the question period.
So what approaches do the other software packages use?
Very often it's hard to say. Very often there's no documentation or article describing what it actually does. This is most noticeable in the case of OpenNLP, which did the best, and quite literally there's just no, on the website it doesn't say, please cite blah, blah, blah.
Is it a fair guess that the others don't parse, or do you think they parse?
Oh, all of these programs have used parsing,
Ah, okay.
okay?
So that's not your event.
No. No, that was one interesting fact. They all use parsing, and all for the same reason. They want to identify the noun phrases.
Well, that could still be used as a candidate.
Yeah, you might make the parser, right?
But, I mean, and I believe, I don't remember the details here, whether we used, and I believe, I'm fairly sure they all used my parser, furthermore. Okay.
But they use an inferior version.
Now that's a possibility. I don't remember if they, I don't, you know, at this point I don't remember. It might be that we fed them all the same version from the parser. I'm not sure. At any rate, we clearly did quite a bit better. And that was, needless to say, quite pleasing. And, as I said, the way you should do these things is now to put mine on the web so that other people can beat me the way I beat them. And so there it is. And finally, we're now moving on to full co-reference. And so I hope, even as we speak, Mika's working away. And so far, again, the numbers, we haven't evaluated these other programs with respect to full co-reference. So
When you say full co-reference, you mean all possible indices, or you mean nominals? Or
we mean nominals and, yes, everything, not just pronouns. Again, the literature is filled with numbers that are not comparable, and again, most of the programs are not available. We're going to make ours available, and I'm hoping we'll have some good numbers. And with that, thank you.
time for one or two quick questions.
Ken?
Normally you don't like to use this many parameters in EM,
That's right.
and I guess you're impressed that it works.
I sure am.
Now, with, say, standard logistic regression or linear regression,
Right.
you also wouldn't want to use this many parameters.
That's right.
Or at least there is an old school that would say. Now, I wonder if you could reduce the number of parameters a lot.
You are not the only person to ask
If you,
this
say,
question.
thought about, estimating
Yes,
each of these parameters.
is the answer.
Say, like avoid the joints, or at least
Yes.
limit the joints to pairwise joints. right?
Yes.
Or throw them all in, right?
So I gave this talk at Stanford, and Daphne Kohler and I have a bet,
Right.
$5. The bet is, as far as I can remember, that if I or a student carefully worked on, in particular, a logistic regression version of this thing, it would or would not significantly improve the results by doing some sort of factorization, and I wouldn't need this awful joint. Okay? As part of Mika's work,
Do we have to guess which side of the bet you took and which side Daphne took?
you're certainly, okay. How many people think that I took these? Never mind. I took the
You took the
no,
winning
it would
side,
not
everything.
help, and she took the yes, it would help. As part of the work that Mika's doing, he implemented a version of logistic regression by doing basically by doing maxent inside of EM.
Yep.
And so far, it has given no improvement. None.
But you could use it to throw in much more features like segment. You said that you've tried that and it doesn't help.
That's right. When I say it doesn't help, I mean, so far, given the same set of features, they both work just as well. In other words, it's not as if there's some set of features that I can only put in one way and I couldn't do the other. I can always do them both ways. It's just my joint gets larger. But the point is that no set of features helps one but not the other, as far as I can tell. Yes?
Do you have any sense from what the 30% you're missing is like?
Oh, now that's a good question. What am I missing? A large fraction of that are really hard. Okay? So you get two people talking, and you get constant he's or constant she's, and the program can't figure out who's talking, who's saying, who's being referred to, because there are two folks, and this is, by the way, this would also explain why something like Google 5 grams doesn't help. Because essentially Google 5 grams would distinguish pizza, hopefully, from piano, but it would not differentiate, say, Newt Gingrich from Pelosi. Okay, well, in that case, the gender would do it, but you see what I mean. So a lot of them are that. A lot are, particularly in this version, it has a lot of trouble with first person, figuring out if there's an antecedent there or this is just being used as some sort of, I don't know what. But it gets a lot of first person wrong, and because of this ripple effect, if you go back and you make the initial guess wrong, and therefore everyone else who refers to it, that can have a huge effect. So a lot of it's that. You gain, by the way, 5% if you count two pronouns that are in fact co-referential, if you count them as correct, even if they both don't have the right noun. So that's 5% right there. Okay. So that's 5%. Really hard cases are probably 20%, and then there's some garbage. Oh, and then there's about 5% that we're missing just because the correct antecedent wasn't in the last two sentences of your sentence. Let's see. Who hasn't asked a question so far? You haven't. Okay.
So I fully support your argument about code being available and downloading it to compare.
Mm-hmm.
But as you were talking, I also looked at some of these pages and they don't list what they're doing. I don't know what OpenLP is doing or guitar.
That's right. I don't know either.
So right. So therefore, I have to ask: have you looked at comparing this to published numbers for what we do know the system is, but we don't have the code? And how does it?
Okay. Well, as I said, the closest system to ours is one by Cherry and Bergsma. And our published numbers, unfortunately, they don't, we don't use the same data, and I don't have their data, and at the time they didn't have mine, but now they can get it. So it's impossible to say what these numbers mean, but at any rate, their numbers were about 66 compared to our close to 69.
Okay.
But who knows what that means? As I say, I'm there. So let me give an example of how difficult this can be. The original data that sort of everyone tended to use was from the MUC conferences, the Message Understanding Conference. In that data, they not only told you, well, what they did was they told you which were the so-called markables. A markable is a noun phrase that in fact is co-referential with something else that they also marked. Okay? And otherwise it's not markable. So in particular, all non-referential its are not markable. People publish numbers that you later learn are in fact based on using this fact, that they know what the markables are. This is huge. Okay?
That's remarkable.
Yes. I mean, and people, and they won't specify. I don't think they're being dishonest. It's just that they think in terms of this particular competition, and that's what this particular competition did, and so that's what they're doing, and they don't need to say anything more. But because of this, it's very difficult to know what numbers you can legitimately compare against and what you can't. So that's my diatribe for today.
So can I ask two more quick questions?
Sure.
So
Well,
one
I
is,
think we are 15 minutes over, so.
Oh, okay. So you
I'll
cannot.
ask about
But you can come up here and ask me later. So thank you again.
Actually, the faculty have been asking too many questions, and there are a couple of students
Yeah, but you've already asked a question, haven't you?
No, let's do this. It's 15 minutes past, so let's.
Offline.
Listeners doesn't need to leave.
The students
Three of you
can come up too.